section 9.8 is talking about a power series. We've been studying power series. We've talked about the Taylor series and Maclaurin series. These are both versions of power series. So we've been studying them already. That's not a problem. It's just that they're finally getting around to calling them a power series. Don't forget. Here's your password. So, let's look at the definition. It says, if x is a variable, then the infinite series of the form a sub n x to the n is called a power series. And notice that we typically start our power series here at n equals to 0. It doesn't have to start there. When you get into complex variables and stuff, you'll be studying power series that start at negative values, and sometimes even go to negative infinity for the end. So it doesn't have to start at n equals to 0. But we typically, in this class, are going to start them at n equals to 0. And we can have them expanded just about x, or we can say x minus c. Either form is going to be a power series. The first one looks like our Maclaurin power series, and the second one looks like a Taylor power series. And we're going to have different methods of getting to these power series, but that's going to be in later sections. What we're talking about today is how to determine the radius of convergence for these power series. Where is this power series a good approximation to the function? It's written as a series. When is this a good approximation to the function? All infinite sum. So let's look at the first ones right here. Where are the following power series centered? In other words, what is C? If you look at this first one, what would C be equal to? 0. If you look at the second one, remember it's x minus C. So what is C equal to for the second one? Negative 1, because you have x plus 1 is equal to x minus a negative 1. So C equals negative 1. And tell me about the last one. 1. Because it's x minus c. So it's the opposite sign of what you see there. That's what c is going to be. Any questions on that? Question?
Are you trying to keep that equal to 0?
Not quite equal to 0, but we're actually going to be looking at that whole series and solving for it. In this right here, all we were doing is trying to identify the form for x minus c. So x minus c is a form. So what is c? C would be 1. And x minus c is a form, so c has to be negative 1. So you're just identifying what c is in this first one. But we're headed in the direction that you're thinking. Okay, so our theorem for a power series centered at c, precisely one of the following is true. The series converges only for that value of c, or there exists a real number r, so that the series converges absolutely for x minus c less than r, and this is the equation that we're actually going to end up solving for. Or it diverges, and it diverges when x minus c is bigger than r. And then it could converge absolutely for all x. It doesn't matter what you plug in, it can converge absolutely for all x. The number r is what we're going to call our radius of convergence for the power series. So when it says find your radius of convergence, you're looking for that number r. If the series only converges at c, your radius of convergence is going to be 0. If your series converges for all x, your radius of convergence is infinity. Otherwise, it's a finite value between 0 and infinity. The set of all x for which a power series converges is called the interval of convergence for the power series, and we'll talk about how to calculate that after we practice finding the radius of convergence. Okay, on your handout that I gave you, you have the classwork questions, the quiz questions on the first side, on the front, and on the back you have the steps to be able to find your radius of convergence r. Once you find r, you're just going to solve the equation to find the interval of convergence by solving for x. So I didn't put those steps on here, but these are the steps that are up here. Apply the ratio test. That means evaluate the limit of an plus 1 over an set that value smaller than 1 and solve it for x minus c, that numerical value is going to be r. If you want to find the interval of convergence, you solve it for x, and that gives you the endpoints. You have to check your endpoints to find your interval of convergence. So let's look at an example. Find the radius of convergence of the series n equals 0 to infinity n factorial x to the n. So I have to do my ratio test first. We're going to have the limit as n goes to infinity. An plus 1 would be n plus 1 factorial x to the n plus 1. An would be n factorial x to the n. Are we good so far? Now, how do we cancel our factorials? N plus 1 factorial over n factorial, what does that give you? N plus 1. And then the x to the n, that just leaves you an x, right? I wanted to do that with bluing. So when you're taking that limit, you can take everything except the x outside of the parentheses because n plus 1 is positive. And tell me about this limit as n goes to infinity. It goes to infinity if x is not equal to 0. If x is equal to 0, I better write that bigger. You're not going to be able to read that. If x equals to 0, then you have the limit is 0. Because 0 times n plus 1 is 0. There's no limit to take. So it converges only when x equals to 0. That tells you that r is equal to 0 for the radius of convergence for that. This problem asks for the radius of convergence. If it only converges for one value, your radius is 0. Because the width around one number is 0. Any questions on that? Okay. Let's look at another one then. Find the radius of convergence. This one looks really horrible. Minus 1 to the n x to the 2n plus 1 over 2n plus 1 factorial. Here again, ratio test is what we use for all of these. Now, I am just not going to worry about the minus 1 to a power. Question? Oh, yeah. Let's get those lights. I'm looking at it, you guys can see it. You guys are looking at me, I don't see these lights. Okay. I'm going to not worry about the minus 1 to a power because the absolute value is going to take care of that. So I don't need that minus 1 to a power. I'm just going to plug in everything else. We're going to have x to the 2 times n plus 1 divided by 2 times n plus 1 factorial. All divided by x to the 2n plus 1 over 2n plus 1 factorial. What do we do with that fraction in our denominator? Flip it and multiply by it. Now let's look at our exponent of the numerator up here. What does that become? X to the 2n plus 3. Over 2n plus 3 factorial times 2n plus 1 factorial over x to the 2n plus 1. Now let's start canceling. X to the 2n plus 1 and x to the 2n plus 3 leaves x to what power in our numerator? Second power, right? Subtract your exponents. 2n plus 3 minus 2n plus 1 gives you 2. And then the 2n plus 1 factorial and the 2n plus 3 factorial. That's going to cancel. You'll have a 2n plus 3 times a 2n plus 2 and then the 2n plus 1 is where it canceled at. So this becomes our limit as n goes to infinity of x squared over 2n plus 3 times 2n plus 2. What is that limit? No matter what x value you put in, what happens when you take that limit? 0, right? You're dividing by huge numbers. As n goes to infinity, your denominators are huge, so that limit has to be equal to 0. No matter what x value you plug in, that limit is equal to 0. So that means r is infinite. Any questions on that? Question? Because I know that 2n plus 3, 2n plus 2 is always positive. I could have said the x squared is always positive too, but I'm trying to keep us in the habit of keeping that in the absolute values because we take the square roots of both sides of it, and then you have to put a plus or minus on it in our next step. So I'm doing that more or less as keeping us in the habit. We could drop it at that point. It doesn't matter. Okay, let's do this one together because our answers are going to be strange. I haven't showed you one like this one, but this one goes on our quiz sheet. So tell me, go ahead and start solving this until you take the limit, and then I'll show you how to get to your final answer of your radius of convergence. So first, do the ratio test. Go ahead and do the ratio test, and then I'll help you get to your radius of convergence from that limit.
So then this gets your cancel out. Yeah, understand my
Okay, did everybody do the ratio test? And you get what you get for your answer of your ratio test. Yeah, so limit as n goes to infinity, your an plus 1 over an was equal to x minus 2, right? And everybody put that in absolute value, correct? Okay, now we have to apply the ratio test. The ratio test says it converges under what conditions? Limit less than 1. So apply the ratio test. That means we want x minus 2 less than 1. That value right there is going to be r. So the radius of convergence for this one is r equals to 1. And that's what you have to do to finish that question. The ratio test, so you want the limit less than 1. So you just take whatever it was that you had for your limit, set it less than 1. And then r is equal to that value. Now suppose that your limit as n goes to infinity, an plus 1 over an had been, I don't know, 2x minus 3 in absolute value. I want something I can factor. 2x minus 6 in absolute value. We would still say we want it less than 1, but we want it in the form of x minus c. So I have to factor out the 2. In this case, r is equal to 1/2, because this is the form that you have to put it in. You have to have it in the form of x minus c, not something times x. It has to be x minus c. That's the form you're looking for. Once you have it in that form, all the numbers are on the other side. Whatever numbers are on the other side is your value for r. Does that make sense? Okay? Did we get that problem done on the quiz? All right. Let's continue then. We are going now to looking at intervals of convergence. Find the interval of convergence of x to the n over n. You're doing the same thing. You have to get to the radius of convergence. And then we're going to go on and find the interval of convergence. So I have to apply the ratio test. Limit as n goes to infinity. I'm going to have x to the n plus 1 over n plus 1, all divided by x to the n over n. What do we do with our denominator? Flip it, multiply, so we have x to the n plus 1 over n plus 1 times n over x to the n. Now let's start canceling. X to the n and x to the n plus 1 leaves you x. And then we're going to have the limit as n goes to infinity. I'm going to write this as n over n plus 1 times the absolute value of x. Keep x in the absolute value. What is the limit as n goes to infinity of n over n plus 1? Infinity over infinity, L'Hopital's rule gives you 1 over 1, which is 1. So that's this part right here is going to go to 1. So I get the absolute value of x. Apply the ratio test to get and we have absolute value of x is less than 1. There's no constants next to x, so I know r equals to 1. The second step is to find the endpoints of the interval. Now we do that by taking our equation, absolute value of x less than 1, whatever that equation is, and I'm going to get rid of the absolute values on it. So when I do that, I'm going to have minus 1 is less than x is less than 1. That's what the absolute values tell you. Make negative, put it on the left, keep it positive, put it on the right. These are my endpoints right here. So I have x equals negative 1 and x equals to 1. Now I have to check and see if the series converges or diverges at the endpoints. So let's check the endpoints. When x equals to negative 1, plug it into the original series. We're going to have negative 1 to the n over n. Does this series converge or diverge? Converges. Why does it converge? Alternating series test, or we called it our alternating harmonic, which I showed you converged. So let's actually check it. Let's do the steps to check it. The limit as n goes to infinity of 1 over n equals 0. Good. And is 1 over n plus 1 less than 1 over n? Yes. So this one converges by alternating. So I know it's going to converge when x equals a negative 1. Let's check x equals to 1. That series is going to be 1 to the n over n, which is simply our series 1 over n. Converge or diverge? Diverges. Why? Yeah, by p series. Or it's a harmonic series which diverges. So the interval for this one is going to be brackets minus 1 parentheses 1. Brackets if it converges. Parentheses if it diverges. Brackets if your series converges, parentheses if your series diverges. So there's my interval of convergence for this series. I told you we'd get back to those tests again. Question?
Yeah, for the very top with the absolute value, are you only putting your x value in the absolute value?
Yeah. You drop all your minus signs and everything else from it. Just keep the x values up.
And like you're doing the test to find the limit, and then you're putting that always less.
Always less than 1.
And did you just skip over it and say R equals 1 all the time?
No.
Why?
Your second homework prompts can have R equal a different number.
Okay, well, if we're always putting whatever we try less than 1, how do we know R?
Suppose you get something that looks like this. Then you have to factor out the 2 and divide it over and you have R equals 1/2.
So,
Yeah, so in your limit, you got this. Solve it. You have to have x minus c. It can't be 2x or 3x or 4x. So if your original question has something times that x there, then you're going to have that happening. That's a good question. No, R is not always 1. It will be different things. Okay, find the interval of convergence for this series. That means I have to apply the ratio test. I have to first do the ratio test. Limit as n goes to infinity. The absolute value, I don't need to worry about minus 1 to a power because the absolute value will remove the minus 1. We're going to have x plus 1 to the n plus 1 over 2 to the n plus 1 divided by x plus 1 to the n over 2 to the n. What do we do with that fraction. Flip it. X plus 1 to the n plus 1 over 2 to the n plus 1 times 2 to the n over x plus 1 to the n. Now let's cancel. 2 to the n and 2 to the n plus 1 leaves you 2 in your denominator. And x plus 1 to the n, x plus 1 to the n plus 1 leaves you x plus 1 in your numerator. So you have the limit as n goes to infinity of x plus 1 over 2. What is that limit? There's no n's in it, so it's just our x plus 1 over 2, right? Our second step is to apply the ratio test. So now we're going to have x plus 1 over 2 less than 1. What should we do with that 2 in the denominator? I would suggest multiplying by it, because we have to get it to be x plus something or x minus something. So that says we have x plus 1 is less than 2. What is our radius of convergence? 2. Now we have to find the endpoints. So I'm going to solve my equation, x plus 1 less than 2. That means I'm going to have minus 2 is less than x plus 1 is less than 2. We're trying to get x by itself, so I'm going to subtract the minus 1 all the way across. What is minus 2 minus 1? Negative 3, less than x, less than 2 minus 1? 1. Check the endpoints. So I'm going to check x equals a negative 3. Plug that into the original series. What is negative 3 plus 1? Now, watch very carefully. This is a negative 2 to the n. This is a 2 to the n. If I can make this into a 2 to the n, then I can cancel them. So let's write this equal to negative 1 to the n, negative 1 to the n, and 2 to the n. Split that apart. And now my 2 to the n's are going to cancel. But what is negative 1 to the n times negative 1 to the n? Yeah, negative 1. I have n plus n gives me 2n. What is negative 1 to the 2n? What is negative 1 to an even power? 1. What is the summation of 1? Infinite number of times. Infinity. So this diverges. Diverges by nth term, actually. The limit as n goes to infinity of 1 is not equal to 0. You guys had one like that on the test, if you recall, except I think it was a 2. Question?
Why didn't you, when you split apart the thing, and you split it as negative 1 and 2?
Yeah, because this is a negative 2 term, negative 1 times 2.
Right. So why didn't you combine the negative 1 and negative 1 to the end by just multiplying the, can you combine them by multiplying?
No, not the bases. When you're multiplying two things with exponents that are the same base, you add your exponents. Think about 2 squared times 2 cubed. You get 2 to the 5th. You don't get 4.
Right. They have the same exponent, and that's why you agree to split the other degree.
Now, this is what you're getting confused on. If you have 2 cubed, 2 to the 4th, what do you get? 2 to the 7th. So if I have minus 1 to the n, minus 1 to the n, I get minus 1 to the n plus n. You don't multiply your bases. You add your exponents. when you have negative 2 to the n, that's equal to negative 1 times 2 to the n. Take your exponent through. Yeah, that's our rule of exponents. Okay, so let's look at the second endpoint. My second endpoint was x equal to 1. Plug that into our series. What is 1 plus 1? 2. So minus 1 to the n, 2 to the n over 2 to the n. Can I cancel anything? 2 to the n's. This is minus 1 to the n. What is the limit as n goes to infinity of minus 1 to the n? It's either minus 1 or plus 1, right? If it's even powers, it's plus 1. If it's odd powers, it's minus 1. It's not equal to 0, and that's all I care about. So this diverges here again by nth term. So what is my interval? Running out of room. I'm going to put the answer right here. It's open, negative 3 to open 1. Parentheses around both of them. Any questions on that process? Okay. Can we do that on our homework? Maybe? You guys get to try one. Find the interval of convergence for the sum x to the n over n squared. Okay guys, so you get to something that looks like this as a limit, right? Did we get to that as a limit? Okay. Take the limit inside your square. And then divide everything by highest power of n. And finish it. You can also do L'Hopital's rule if you want. That was just a method I grabbed first in my mind.
So did you publish your you guys So this one is, one is, we have one square. And then this one's the lightest one, and that's
How did that's good old
okay, so you're putting your money in power, so you're actually going to understand. And so you recognize this as being no. So if you check out the cycle, it's outside audience. So this yeah. And then this one is exactly what it is.
Why?
I had jeans on this morning.
Yeah, it's similar to the
Creative is one I told you.
I feel like that garage across one side, where it's like, wait. Dr. Anderson will have a very amazing, so. Oh! Alright, send
Oh, well, yeah, well, apparently.
I know, I got applied for the lights, yeah, so I'm looking at
She's so crazy, it's not
Oh,
even.
I think it's less than or even.
I know that they are because so right now, they're totally but I mean, like, what they do, yeah, it's on. 40 hours. Yeah. And at that time, if the requirements of that hours, or not a bad hours, we give you an automatic. And
Except
so,
that I would try to go on the director's school.
yes, but they, alright, but they don't have time in this day, so they have recreational, yeah. It's through the Department of the Army, and it's the agency that's in charge of Army installation unit. So it's a lifeguard.
The only thing that must be the class that were trained out by the army, and yes, those training rules probably go on with the same ones the training Coast Guard. Those are. You guys get it to work?
Office. Yeah, office.
Amazing, it
So the first one is, we keep working back on these series, myself,
is. We're just absolutely like, seriously, but else is like.
Dracula.
It doesn't matter. You might as well, they do.
I like some parents just doing something great. Oh. And it's the.
Yeah, but if you want to say picture to shape
Surveys.
picture, say water.
For the department.
What it does is that it just puts that part of the property.
I think our department maybe have scientists, workers,
Is this all?
I could work with the naval warfare, surface warfare center. You know, that would be pretty cool. Work with embassies and there's a department. No, this is the federal government job. So you can go anything federal. Department of Commerce, Navy.
I had someone when we worked with his brother in the Navy.